Tonight's law of exponents that we're going to discuss is called power of products. That means if within the parentheses you have a product, 2 times x, and you raise the whole product, the 2x to the 4th power, what happens? And that's what we're going to figure out tonight. Just like the last few nights, we're going to start by completing a table, and we're just going to be looking for patterns to see if we can find a more efficient way instead of writing out a series of factors in expanded form to get to single exponents. So what I'm going to do is I'm going to walk you through the second row, and then you'll pause the video and try the first and third rows yourself. So if we have 3 squared a to the 4th all raised to the 4th power, what does that mean? Well, that means that you must have 3 squared a to the 4th times 3 squared a to the 4th times 3 squared a to the 4th times 3 squared a to the 4th. If the exponent here is 4, it just means we have 4 of these factors we need to write out. 4 of whatever's in the parentheses. 4 copies of that multiplied together. So then we can regroup using our commutative and associative properties, and we could have 3 squared times 3 squared times 3 squared times 3 squared times a to the 4th times a to the 4th times a to the 4th times a to the 4th. And then you'll remember when we're multiplying, we have the same base. We simply keep the base of 3 and we add those exponents. 2 plus 2 plus 2 plus 2 times, keep the base of a, add the exponents, 4 plus 4 plus 4 plus 4. And that becomes 3 to the 2, 4, 6, 8. A to the 4, 8, 12, 16. And if I don't put a multiplication sign in between, that's fine. If we don't see a dot in between those for multiplication, multiplication is assumed between those two factors. All right, what I need for you to do is I need for you to pause the video, try out the first and third row, and then we'll get back together and talk about it. All right, hopefully you paused the video. In our first row, we have 5f squared all raised to the 3rd power. So that means 5x squared times 5x squared times 5x squared. 5 times 5 times 5 is 5 to the 3rd. F squared times f squared times f squared, 2, 4, 6. F to the 6th. In the last row, 3x to the 4th all squared is 3x to the 4th times 3x to the 4th. 3 times 3 is 3 squared. X to the 4th times x to the 4th, 4 plus 4 is 8. And what we're wondering is instead of writing out an expanded form every time we want to raise a product to a power when working with expressions involving exponents, is there a more efficient way to go about this? Well, let's just take a look. We'll start at the middle row where I first started. And I'm just going to take a look here and say, is there something I can do with my exponents? I have this exponent of 2 on the 3, an exponent of 4 outside the parentheses. Is there something I did with that 2 and that 4 to get 3 to the 8th? Well, what I did was 3 to the 2 times 4 is 8. Then I look at my exponents on my a's. I have a to the 4th, all raised to the 4th power on the outside. What could I do with that 4 and that 4 to come up with 16? Oh, that's a to the 4 times 4 is 16. It appears to me as though if you have exponents within the parentheses and you're raising that entire item in the parentheses to a certain power, you just multiply what's on the outside of parentheses, that exponent, by each exponent within. That's what it looks like to me, because 2 times 4 is 8, 4 times 4 is 16. Let's see if that works for the third row. Well, we know 3 is the same as 3 to the 1st because there's one factor of 3. So let's do something with that 3 to the 1st and the exponent of 2 on the outside of parentheses. What do I do with 1 and 2 to get to 2? Oh, 1 times 2 is 2. That's 3 to the 1 times 2. Now let's look at this exponent of 4 on the x, and then still the 2 on the outside of parentheses, because that whole item within is being raised to the 2nd power. So 3 is being raised to the 2nd power, and x to the 4th is being raised to the 2nd power. So what can I do with 4 and 2 to get to 8? Well, guess what? That's x to the 4 times 2 is 8. So in our first row, let's hope it works for that first row. Exponent on the 5 is a 1. 1 times 3 is 3. That's 5 to the 1 times 3. Let's check here. F to the second raised to the third power. 2 times 3, f to the 2 times 3 certainly is 6. So it appears as though every time we want to raise a product to a power, when working with exponents, what we do is we multiply each exponent within the parentheses by the exponent outside the parentheses. So it looks to me like you take each exponent within and just multiply it by the exponent outside the parentheses, because outside the parentheses tells you how many factors of each term in that product you have. So let's take a look at our power of products law. It says xy to the nth power means x to the nth times y to the nth. So ab to the second means a to the second, b to the second. And he says, so when I take a power of a product, I apply the exponent to all factors of the product. So the exponent on the outside of parentheses gets applied to all factors of the product within. What I'd like you to try to do on your own is to rewrite each expression using single exponents on each factor. So what I need you to do is pause the video, try it out, and then come on back. Okay, for the first one, if you needed to, you could have written out 5xy squared 7 times. Then you'd see 5 times 5 times 5 times 5 times 5 times 5 times 5. We have 7 factors of 5, so that becomes 5 to the 7th power. And then you see x times x times x times x times x, and so on, 7 times. That means x to the 7th power. And then finally, y squared to the 7th. We have 7 factors of y squared. How many factors of y squared do we have? Oh, we have 14 factors of y squared. 2, 4, 6, 8, 10, 12, 14 factors of y squared. What's a more efficient way to go about it? You can just think of this as 5 to the first. 1 times 7 is 7. X to the first. 1 times 7 is 7. Y to the second. 2 times 7 is 14. So if you need to write all the factors out and then just apply your laws of exponents, go ahead. Or if you want to just think about it as a product to a power, you know that that power is given to each factor in the product within, applied to each factor within. So again, for the second one, you may have chosen to write 2w to the 5th x to the 9th out 4 times. How many factors of 2 would you then see? You'd see 1, 2, 3, 4 factors of 2. So that's 2 to the 4th. How many factors of w would you have? You'd have 5, 10, 15, 20 factors of w. So that's w to the 20th. And how many factors of x? You'd have 9, 18, 27, 36 factors of x. So that's x to the 36th. And then here I could have simply applied my product raised to a power of a product rule. So 1 times 4 is 4, 5 times 4 is 20, 9 times 4 is 36. So that could be 2 to the 1 times 4, w to the 5 times 4, x to the 9 times 4. And you could have done that and still gotten to the correct answer. Next step is to show or prove in detail why x, y, z to the 4th becomes x to the 4th, y to the 4th, z to the 4th for any numbers x, y, and z. So take a minute, pause the video, try it out, come on back. All right, so let's take a look. So if we start with x, y, z to the 4th, the way that we can prove that is first we just write out in expanded form x, y, z times x, y, z times xyz times xyz. And then we're going to apply our commutative and associative properties for multiplication to get our next step. So in our next step, we could do x times x times x times x, y times y times y times y, z times z times z times z. And what our commutative property says is we can change the order in which we multiply. It won't change the outcome. Our associative property says the way in which we group what we're multiplying together won't change the outcome. So let's see. This is x to the first times x to the first times x to the first times x to the first. That's x to the fourth. Y to the 1, 2, 3. There's 4 factors of y. And then there's 4 factors of z, and we've just proved it. And this is just using the definition of what it means to raise to a power. If you want to use words to also help you describe what you've done. Now, in your own words, I'd like you to describe this fourth law of exponents, raising a product to a power. I'd like you to use words and an example if you're able to. Come up with your own example and talk yourself through it, how you're able to apply product to a power rule. Hopefully you do a nice write-up on those. We'll see you in class tomorrow. Take care. Have a good night. Bye-bye.